Yeah, welcome to today's webinar. The topic today is how to be more productive using RFEM. My name is Andreas Hörold. I'm responsible for marketing and public relations by Dlubal Software. For instance, the Dlubal website, the press releases, and the German and English webinars. I will be the moderator today.
Yes, and I will work with Andreas today as a moderator. I will be the presenter. My name is Walter Rustler. I am responsible for sales and special cases of customer support at Dlubal. And I will show you hopefully very interesting features today during this 1-hour webinar session. So, Andreas, I think you give us a short introduction in what's going to happen in the next close hour. So go ahead.
Okay, at first we stop the sharing of the webcam. So, okay, that the attendees can see the whole screen. That's good.
Exactly.
Okay, on the right side of your screen, you can open a control panel where you can ask questions via chat. I will answer you. If you don't get an answer during the webinar because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. You can see the address here on the left side of the screen. To the agenda of today's webinar, Walter will introduce features about the model generation, the parametric models, the load input and generation, for example, the wind and snow load generators, and for of the evaluation of results and documentation. He will also describe the advantages of these features. Yeah, okay. Before we start, or before Walter starts the presentation, I have one question. I launch a poll.
It would be great if you could answer briefly yes or no, whether you already use the software. It's always interesting to us to see who we have on the other end of the screen. Yeah, we are quite good crowd here today, and just select yes or no if you use or do not use the software. It's just interesting to see what's the relationship. So give you a couple minutes.
Yeah, I see the most of you are already using RFEM or RSTAB. Maybe I can show the poll.
Show the results.
Yeah.
Okay, so 85%.
Yeah, that's a lot. But I hope that you will get to know something new and yeah, how you can use these features that Walter introduced for your daily work. Just another info, the webinar will be recorded. If Walter is too quickly for you, you can watch the entire webinar later. At the end of the webinar, I will show you our website where you can find the models and the recording. Now enjoy Walter's presentation. I hand over the screen to Walter. Walter, it's your turn.
Yes. Okay, I have to change to the right screen. So I think you should see now my screen. And yeah, thanks, Andreas, for your introductory. And yeah, I know there are a lot of you who already use the software. I'm sure you have seen specific features and you know about them, but nevertheless, I give you a quick run through, I think, to the most important or very important features that boost your productivity when you work with RFEM. All the models that you see, we will also provide for download later on, so you will have the chance to check them out in detail. So we can run through rather quickly to all the examples. And with the video, I think you have a great way to analyze every details later on. And if there are still questions, do not hesitate to contact us on our website or via the email that Andreas pointed out to info@dlubal.com. We'll gladly get back to you. So first section of the presentation will be about the model generation. The first example I'm presenting is the feature to generate surfaces from members. This will help you to quickly create quite sophisticated features of models from members, from 1D elements and will be transformed into shell objects automatically. This is a feature that comes with RFEM. You don't need any external CAD program or spend time to manually draw the lines and the surfaces and openings and so on. It literally by one click creates these models. And I think it is often useful to analyze local effects of, for example, where load impact areas are or where you have local supports, while with a member you just have a beginning node and an ending node. But for example, with an I-beam, you don't know if the support is really at the bottom flange or it's hanging on the top flange and so on. So how do we do this quickly? It's quite simple. We create a new member. In this case, it will be an I-beam with openings in there. So for example, an castellated beam with circular holes. You have the option to enter or define this castellated beam just with parameters like the diameter or the distances of the holes, and the software will then automatically create an equivalent stiffness for this cross section, and you have a way to model such beams very quickly. And when doing this, at the beginning, we just please note, we just enter a 1D element, just beginning node, ending node. The visualization there is just a visualization. Basically, we know nothing else but the center line and the member. So right click on it, and then you have generate surfaces from members. We can create some supports, in this case, some line supports, hinged on one side and a roller support on the other side. Yeah, and then quickly we can analyze this member. It automatically meshes. You get now results for the surfaces, and it's not a 1D element anymore. You see all the details. You can find the hotspots, the stress peaks, and so on. And also, of course, a design of a castellated beam is a different way than with just a 1D member, which is basically not possible with a 1D member so easily. Okay, that was the first feature. I'm sure majority of you already knew this, but it is very important, I think. Next feature I'm gonna show you is also a specific feature. You don't find it in a lot of programs. It was a client wish from one of our most important clients. It's a client that sells and engineers cranes that you all have seen and known. And their wish was to have a model or an element, cable element that runs around a roller. And if you don't have this, you will see that we cannot do a correct analysis. There are two very simple crane models in this picture. On the right side, we're using regular cable elements, and we throw them around the crane, with certain points where you usually would have pulleys. And there is for this example, just a plain simple nodal load of 50 kilonewton on the end. And if you pull on this cable with 50 kilonewton, you would imagine that all the force or the same force goes through the cable. But what you see now here is there is a much higher force in that cable due to the reference, or to the relation of this model here and the stiffness of the crane. And it's, for example, here 100 kilonewton. And on the other side, we have the cable on pulley element, and you can see there's also 50 kilonewton in force. It pulls down and it goes more or less constant around along the cable. So what we've learned here is, if you don't have such an element, you cannot analyze such things, because everything is in motion, and if you cannot model the cable that slides around or rolls around that pulley here, you will get wrong results, not only in the cables but also in the structure itself. And for us, it's quite in our software, it's quite simple to model. You just choose the member type cable on pulley, and that's all you need to do, and you get then this effect in your structure. Next feature is a little bit more related to building. It supports from walls and columns. If you look at this little slab here, you see there is supports around the edge of the slab, and in you not always use a 3D model to analyze your structure. Sometimes it's of advantage if you have only individual slab that you can look at in detail, but then you need to introduce the support reactions at the edges, or where the walls usually would connect. And if you, in a simplest case, you can put there a linear support, a rigid linear support. It will work most likely, but it can also lead to singularities, because we have very rigid connections, and it's not realistic. So this unwanted effect you can avoid by using the stiffness tool from walls and columns. We can also take into account different support conditions, and I show you quickly how this works here. First, you select the support, and then you have the wall in C direction as an option to get the elastic support conditions from. You click on the details or settings icon there, and then behind there you find the definitions of, for example, the width of the height of the wall, and what material it is, and how the support condition is at the wall end on top and on bottom. And depending on this, you see on the right side there is the support springs to the wall that are calculated at runtime when you change the parameters here. And for example, you can set a 3-meter tall wall, and you get the stiffness automatically behind that support condition. So you don't have to manually calculate your own stiffness. The same is possible with a point support. Same strategy. Just click on the edit button, and you will find the possibility to select the stiffness of the wall with the length and the cross section of the column. Very useful and very helpful if you pull out some part of the structure from a BIM model, for example. Also, you can display these walls and columns inside the model, so it's good for understanding where the stiffness comes from and how things are related in truth. Okay, next feature is called intersections. It's a very powerful thing. We spend a lot of time in developing it, and here's a very simple example, but you can basically intersect all types of surfaces, curved surfaces with other curved surfaces, and basically we remember the intersecting line from the base geometry. So if you have a general curve and another general curve and they intersect, then the program is able to calculate automatically this intersection line. If you change the surfaces, it will automatically recalculate this line. So I've seen other programs where you have to create some kind of mesh in a CAD application, and then you import that mesh, and then you analyze it after so and so long time. But this is all built inside RFEM, and you can just simply generate it. So we right click on the surfaces and we generate the surfaces directly from it. And you'll see first the surfaces are intersected, and in the surface navigator, you see then components that can be set active or deactive. So now we have cut these two pipes together, and we have the cutting or intersection line, but we need to cut off certain parts of the structure, and that you do by activating or deactivating those components. So you just right click on it, and now you can say deactivate, and then we will not consider this part of the surface in the analysis. So very intuitive, very simple to do. We create a short load case, self-weight, for example, and to prove that you can analyze this, we can just quickly enter some support line, and we can run the analysis. You maybe also have noticed, or we'll see then when we see the mesh, there is a fine mesh. When you generate the surfaces, you can set up the mesh refinement, or if you want to use a mesh refinement while you generate such intersections. As I said, it works also with more complicated surfaces, not only with those two pipes, but very quickly. And if you change the diameter of the pipe, it will automatically recalculate. Next feature is about ribs. Often you have the situation that you have to set members underneath a slab, and they have to have a certain eccentricity that it's depending on the depth of the member and the thickness of the slab. And you can automatically, let's say, or manually recalculate the eccentricities or put in their rigid links. We have a very fast tool that's called RIBS, and it allows for more realistic analysis, because if you have an eccentric beam, it will take axial force through the eccentricity, and we don't need manual analysis of such eccentricities. When we start with it, here we have a simple grid, all is centrically modeled. Now you can see it's just lines behind the 1D elements. We create a rectangular concrete slab with a certain thickness, so in this case 250 millimeters. Quite simple from one point to the other. So, and now we can set all these beams eccentric to the surface. So they just connect right underneath the surface. So we right click on it, edit the members all together, and we select here rib, and then we define the rib details below there. We tell the software to put the slab on the positive C side of the surface. Also then we can define integration with. So it will integrate the internal forces to this, let's say, extra member that is composed by a part of the slab and the beam, depending on this integration width, and we get then RIP internal forces that summarize the part of the slab and the beam with the eccentricity. Yeah. So that's why you have to define an integration width here. The stiffness is defined independent of the integration width, because we have an eccentric beam and we have the eccentric slab. That is all fine. But for the internal forces, you need this integration width. So now you see the beams are automatically set below the slab. We can choose the rendering options to show also the field models. Typically, we only show the center surface plane, let's say, and to check if it's all correct, you can see the full thickness of the slab, and it's all fine here. Again, we create self-weight internal load case, and we analyze the internal forces. And as expected, we have a different type of force distribution, especially in the slab, you can see it. And if you would show here now the axial forces, you would see there would be also axial forces. But you can see also in the MX internal force display of the slabs that these beams have an effect, and it is very smart feature, because as soon as you change the cross section or you change the thickness of the slab, it will automatically recalculate the eccentricities. The ribs we can then also use in the concrete design for a specific design of the floor beams. Next feature is line releases, a feature that's in there for a couple of years now. It allows to model not only rigid connections like what we've just seen in the ribs, but also elastic connections between a slab and an underlying beam or wall. We define the connectivity of basically a common line of two objects. We can get the connection force as a result. So if you need to design the connection for this of the beam and the slab on top, you can get the forces, and you can take into account also elasticities, you know, and there is all kinds of non-linearities. For example, a connection can act only in compression or only in tension or with a certain stiffness. You see here 5 different models of a similar structure, but the connectivity is differently. So if you have only the slab, okay, there is a deflection of 12 millimeters in this case. If you put a beam that is rigidly connected underneath the slab, for example, as you did with the rib before, you see the deflection changes to 1 millimeter. But then you can also say that the slab just rests on the beam. There is no shear activity, and then we get a deflection of 3.7 millimeters. Or we can add there a elastic shear connectivity, and then the deflection is reduced again to 2.5 millimeters. And I can also say there is no connection, which is maybe then realistically not so true, because somehow those two objects will probably touch each other. But just to check, if we release the release completely, we should get the same deflection as without any beam underneath. How to define such line releases? First, you define a so-called line release type. The line release type has all the properties like of a normal release or a hinge. We have 3 degrees for translation and 1 degree for rotation. You can add here non-linearities, such as tension only or also diagram activity. And then this is your release type, and this release type you assign later on in to a line. So you pick a line, you say, okay, this line should act like this release, and then you have to define which objects. There can be many objects on this one line. For example, there can be 2 surfaces that have a common line, or there can be a member in the surface that have a common line. You say which object should be released. In this case, it's member number 2. And there are some other settings, but typically these are the most important things you need to take into account. And then you can modify the stiffness and the model as I think it's much more realistic for many cases. For example, if you have a concrete slab and a timber beam underneath, or something that's not quite rigidly connected. You will get this model so you can take a deeper insight into it, how it is modeled. And we also have on our website videos and webinars that explain this in more details. Also something that comes with plain RFEM, very powerful tool. I've not seen such things in many other software. Very similar to the surface release, to the line release is the surface release. It's just an extra dimension. With this, you can model contact properties, including all these non-linearities like yielding, tearing, slip, connectivity, compression, tension only. And it's something that we often use in connection models. So I show you now this simple model of a bolt and that runs through an eye, but it has a contact property that is only acting on compression. And you can see that the bolt releases from the right end of the bolt eye. Let's say we have the forces that push the bolts to the left. So it's really a contact problem. We can increase the deformation. We can animate it. You can see how it releases on the right side, and it will lead to a totally different stress picture in the eye of the connection, because it's not glued, let's say, back on the right end of the eye. So the surface release you can just edit in the navigator, and it's also follows the same rule as the line release. You define a type, and there is an explaining picture on the right that shows what happens. We create a double surface, let's say, on one plane, but they are not connected or connected as we define it in the surface release type. The type is again with all the non-linearities, and you can see there can be also, for example, diagram action or stuff like friction and so on. Very powerful feature. This made a big step forward when we were working with connections inside RFEM. So you also will get this model, so you can take a deep look into that. Okay. Yeah, very related to this surface release is the solid with the contact properties. We had this feature before we have the surface releases, but you always had to make a solid in order to have a contact model. With the solid, it has some other advantages because you can basically set the contact properties between parallel surfaces. It's something that it is also not common in software for buildings, but that makes RFEM also a more general FEA software. And you can use it not only for regular building, steel, concrete, timber design, but you can also use it for steel design and just as a general FEA software with a lot of non-linearities. Again, a little bit bigger picture, you can see you have things like failure under tension and failure under compression, and you can have the friction between the parallel surfaces. It's a little bit similar, but it has some advantages when you work more with solids. Okay, these were the features from the modeling of structures. Maybe a quick question to Andreas, if there are some questions already to this, or if we can maybe take a peek at a few of those, or you can just comment on some. How is it going?
I've got a lot of questions. I don't answer. I can't answer all questions. There are too many, I can say. Maybe,
Okay.
but you will get an answer after the webinar. That's no problem. Next days you will get an answer. But there are too many. But maybe we can answer some questions. Maybe we can go to our website. There are a lot of questions where the trial version can be downloaded, or is the ACE implemented? Maybe we can show that pages. Walter, can you show our?
I have a suggestion. We have a block of this where we can show this at the end.
Okay.
Maybe where you go anyway to the website. There's a lot of frequently asked questions, but when I scroll through to some of the questions, I can pick out a few. For example, one question was if we have also ACI code included in the software. I can say yes, of course we have that. We have many international codes. Maybe at the end you can also show where to find this on the website. So everything is really on the website. We have not only Euro codes, there's ACI codes, American codes, Chinese codes, Brazilian codes, Canadian codes. Also, there was a question I saw about dynamic analysis. This is also possible, and there is a set of reference examples, for example, for dynamic problems that we can look at.
There's also a question if the program generates the printout report automatically. It's not completely automatically, but you will show at the end of the webinar some features of the printout report, and the attendee need to wait until you show this feature.
Okay. Yes, it's good that you write to us. Keep on doing this. And we'll get back to you. If we can't answer all the questions right now, we'll get back to you with individual emails. No problem. Okay. Yes, let's continue. Next part of the presentation is about parametric models. When we talk about parametric models, of course, we have interfaces to Rhino and other CAD software. You may just look in our website for webinars for this. This is alone a topic for its own webinar. But what is behind there is, in many cases, our programmable interface or API called RFEM. And it is a great way to automate your workflows. And with this interface, you can really remote control RFEM. You can create structures, you can change them, or you can query result data and after or the post-process them in, for example, Excel. So if you want to say so, you can maybe create your own additional module for it, or your own structure generator. And it's possible to do this in Excel or with Visual Basic or in C++ or C# or other languages. I'll show you quickly one simple example that I did in the training, and in this case it is about a staircase generator, a spiral staircase generator that is controlled by Excel. So I have a simple Excel sheet where I define the geometry, the internal radius, the exterior radius, the distances of the steps, and how thick they are, and what types of materials I want to use. And behind these parameters then will create automatically a model that you see a little preview in this Excel sheet here. You know? So I changed some parameters, and only these, let's say maybe 10, 12 parameters are needed. And then I press the button generate, and you will see behind in RFEM the model will just magically be generated, and you see all the details. Of course, you need to code it and you need to program it. This requires some basic programming interface. I'm not a programmer by myself, but I understand a little bit about Visual Basic, and that was enough to do stuff like this without a lot of preparation. Yeah? So now I see there's maybe we are one step short, so we put there another step. And then after I remove the model, I can regenerate it. Of course, you can also program it in such a way that we also refresh the model and delete it or update it or add it on. So it's just extra work. So now we have the missing step. We can also look into what's been generated. It's a plain normal RFEM model. You can manually change it. It's just an initial start that you get with this generator. It's been used very widely. People use it to make their own work processes very automized. You know? If you click to the code, then you see we also ship code examples with it. If you understand a little bit about programming and a little bit about RFEM, you will have no problem to fill the data. Also on our website, there is a set of frequently asked questions where we explain how to connect to the interfaces and how to do most important things. You see the object library, and in this object library, we also have like a built-in help, and when you install RFEM, there is examples that come with it as well. Same is also possible with RStop. So if we don't talk about RStop today, RStop is just, let's say, a more simple version of RFEM that has no surfaces, but has only members. So if you don't need surfaces or solids, RStop would be maybe an option for you, but we have also an interface like this there as well. Next very nice example for parametric modeling is this simple pipe connection. We have the option in RFEM to enter their parameters. You can define your own set of parameters behind all the, for example, coordinates or load values, and you can make it depending on different dimensions, for example. You have a set of mathematical functions that you can use, and it allows you to make models parametric. And it's perfect if you have simple problems that reoccur constantly, but you just have to tweak a little bit with the dimensions or with the orientation or with the forces. Then once you create such a parametric model, you just change the parameters and everything is then updated automatically. So the way it works, now you see here the parameters. We have, for example, the angle at the left, the angle at the right of this connection. We change the angles. We can change the loads. These are the parameters. Then we update the model, and it will automatically change. And you see also the intersection is there. It's intelligent. It stays connected. If you change it back to greater angle, then everything follows. So it's very powerful once you have created this model. Everybody can use or they can create its own parametric model. This is also a standard feature. It's not that you need to buy any extra add-on or so on. Yeah? So very powerful. Also, this example will be in the set of models we put on the website. Good. Yes, and I don't know, many of you used RFEM, but have you ever maybe used the library of models that we have in RFEM? Because there's a lot of parametric models shipped with RFEM. It's part of the standard installation. Everything is fully parametric, and you can use these blocks, we call them, for either standalone models, or you can merge them with your existing models, and you can create also your own blocks. Quickly, how that works: you select the block with the symbol as a block manager. You open it, and then you get like a simple project manager with a lot of models that you have already in every standard RFEM installation. So you don't have to, for example, those trusses, you don't have to model them yourself. You can automatically create them with these blocks. There's member-based structures, but there is also then surfaces, or also solids, different types of slabs and curved slabs, cells, and different things. And as you like, you can also extend it with your own creations. If you click on it, then you see a preview of the block. You see the parameters, which are basically the parameters of these parametric models that we showed before. You can also define the relative position of the block when you or merge it with an open existing structure. Yeah, and you change the parameters, and the model will live follow the changes. You can tweak it as long as you want, and until you get your final dimensions. And if you click OK, it will insert it in your empty or existing model. And to prove that it is really a fully functional model, we will just add a short load case and run the analysis. So very powerful feature, often used to merge certain parts of buildings, for example. Okay. Yeah, then we continue to the next section, which is the load input and generation. Wind loading is a quite interesting topic. For regular buildings, there's often analytical ways to find wind loads in the codes. We have with our wind a digital wind tunnel, but this is a different module, and you might want to browse for our wind on our website, which allows you general wind simulations. But if you have regular buildings, such as this building here, it's quite easy to get code conform loads. Yeah, and it distributes all these area loads to members based on different codes, Euro codes, but also, for example, American codes, and of course we have all the national annexes. And this is then also an object. That means it's connected to the structure. So if you change the dimensions of the structure, the load will follow automatically, because it's not depending on a certain load value. It's depending on the geometry and the parameters that we have. And we quickly show you how that works. So you can generate those loads with tools, generate loads from wind loads or from snow loads. We'll take a look afterwards. And then you have different options and different codes that you see here that we can use. We'll use Eurocode, for example, and then the code parameters are showing up in a form. You choose the national annex. Then you need to know some territory parameters, if it's inside the country, at the sea, or somewhere at a certain exposure. Then we pick where the base geometry of the building is, so the program knows, okay, which direction the wind acts from. We also, if you want to add the load also on the roof, we have to pick the roof geometry. So quite simple, just visually pick all those nodes, and all the members that are inside these surfaces are now automatically classified in which impact area the load is. You see here A, C, E, these are the load effect areas, or according to Eurocode, and we can deselect certain members from activity. For example, the main girders, I just want to have the loads on the purlins, and the purlins automatically distribute the load on the main girders. So in this way, you can also model some one-way force distribution. So now not the forces are not redistributed on the main beams and the purlins, but only on the purlins. So it's just one direction that is loaded. Yeah, you define, you get a summary of all the loads that are applied, and you see now the load is just decomposed into linear loads according to the code. There's no loading on the main girders because we excluded them from activity. And I can display just a symbolic mode where I don't see the individual member loads. Sometimes this is a better overview, or you can say I want to have them separately and see exactly what the program did. So this is an analytical way, and if you want, you can edit it as a whole. So you're not editing the individual load. You can do this as well, but if you click on it, you can change the entirety of this load picture. And we also can set up certain features, like what the tolerances are out of plane, and whether at if I want to check certain modes, it's really well, you don't really need to go into this dialogue so often, but you have some tweaking option. So for example, now I can say I only want to have the loads on the columns and not on the roof at the same time. So now you can see that the purlins at the edge of the roof or the main girders at the edge of the roof don't get any horizontal loads because everything is assumed to be transferred straight into the columns. Just an option that you have. Good, that was the wind load generator. The snow load generator is a very similar tool. Again, for regular buildings, different codes, and works very similar to what we've seen with the wind load. It's already entered here. You double click on it, you change the entirety of this load. For example, you see here the national annexes that we support. Then If you talk about snow load, we need to enter the snow load zone and the altitude of the building, and it will automatically recalculate the snow loads depending also on the inclination of the roof. Yeah. So when we change the parameters, you see it here at edit parameters, you get into the list of parameter because this is a parametric building, you know, as I showed before. And because it's an intelligent load, it recalculates when the structure changes. If I change, let's say, the spacing of the beams or the frames, you know, with a mouse click, also the load will follow. So you don't have to program it yourself. The software itself is smart enough to do this, and you can build a very powerful tool with it. Also, you will get this model in your download option after the webinar. Okay, this was the snow load generator. Yeah, I have to look a little bit at time. We come now to the last part of the presentation. We talk about result evaluation and documentation. Here we show like the result diagrams. It's quite well-known feature, I think, but not everybody knows what you can really do with it. You can easily create such things. You can smooth regions, and it's an object, so you can really copy it, and it allows for a better, let's say, interpretation of the results in the engineering way, I would say. So we have a simple model here. We create a section. You just can click on the grid points and draw the section from one end to the other. It will open a window, a section window, and you have at the left a navigator where you can set up all the results that you like to see. Yeah, all the results that are possible you can select at the left, and it's you see the section, the diagrams of the forces underneath, so you can compare, you can read the values and so on. You can save the section, so it's an object that's built inside the model. Once you close it, you see it also in your model itself. Sometimes if you put in, if you display the result values on each mesh point, there's so many values you don't understand, where you can't read them. But this way is a very, let's say, clever way, I would say, where you can show results in sections and at points of interest. And it's easy because you can also select the object, the section, copy it like any other object with a certain distance in a certain direction, and it will show you multiple instances of those sections. I think it's also a very, very interesting way, and you should think about it, whether it's possible or it's a good way to document your results. Yeah? When I go to the result diagram again, you have the option to edit so-called smooth regions, where we can average out the results in a certain area. We define just the start and the end of the area, the length. On the top of the screen, you see also the dimensions, so you know a little bit where you are, where you can grab it from the picture. You can say where I want to apply it, to which force, and you can see a little symbol now at the MX force, and it gives you a green line with the average value and the integral of the, let's say, cut-off peak value. So it's a good way to work with such values at points where there are singularities or peaks that are not realistic. Typical problem in finite element analysis. Very powerful tool, I think, also. Result diagrams, copying. Support reactions, similar thing. You can get the support reaction lines. You can display the results also out of plane. So if you have top view and the forces act in C direction, then you don't see the course of the force. But if you flip them to the XY plane, you can still do a good documentation, and you get things like sum and center of forces and the result diagram. So also briefly shown on the same model, we show the diagram of the linear forces, and then if you go to the display navigator, the support reactions, you see the smoothing options. You can show the sum and the mean values and so on. Yeah? So now we use the smoothed results. So we basically average out all the forces along the line, which is also commonly done in engineering. We can change it to linear or to trapezoidal distribution. And also you can get different info like the info about the sum of each support line, where the center of the force is, what's the resulting moment around the center. So this gives you also a great control about the forces that actually come down from a wall or from a slab into a wall. Forces are now flipped into the XY plane. So when you view from top, you see also the forces. So this is also very good for documentation if you print it to your printout report. Okay. Yeah. So again, the different options and how they work and where you find the switches for it. At the end also, when you right click on a linear support, you can get the result diagram as shown before in a result course. And there you have the same options, also it's the same tool, but you can read every value. You can export a table to Excel, for example. So it's also very, very powerful just to read and look into your system and to understand what really happens there. Another engineering tool is the so-called average regions. With these average regions, we can smooth values on singular areas, and we can cut off the peak values and use them also for design. It's a very practical thing that engineers do, and it's it avoids you have it all in the software. You don't have to make handwriting or whatever in your printing. You can explain, you can, let's say, tweak your results in a way like engineers used to work and cut off such peaks like what we have here. The way to do it is you create a new average region. You find the tool in the navigator, in the data navigator. You select the surfaces that you want to smooth. So in this point, we have 3 surfaces that are touching this column point here, which is modeled as one single node support. I pick the center of the smoothing region and the dimensions of the smoothing region, 1 meter, and which internal forces I want to average through all surfaces, and it will cut off the peak. Not cut off the peak, it will actually redistribute it. It's totally fine what you do here, but you see here now the peak is gone, and I can set up the design modules that they design not the peak, but also only the smooth region. And you see here also we have 76.7 as the major magnitude in this MX force distribution. And if I use the unaveraged result, I have 112. So, I avoid undesignable situations there with this engineering habit, I would say, which you find in this practical software. So that was the average regions. Next is the mass print tool in the printout report. I saw there were also some questions in about reporting. So reporting is possible, of course. The reports are automatically linked to all the data, so it updates as soon as you change the data. Now, when we print, we always follow the situation that we print what we see. But if you have, let's say, tens or hundreds of load cases and combinations, it maybe is painful to print every picture. That's why we have the so-called mass print tool. And it will take care of automatic printing of pictures and forces for different load cases with an optimal arrangement on the paper. And it will be updating as soon as we change the structure as well. So we have a simple 3D building here with bending moment results, for example. For example, now we cut out one frame here. We place the picture as we like to see it in our printout report. We hide the rest. We put it into the right aspect, put the forces in the right size, maybe disable the rendered view. So now we have what we typically would like to print in the printout report. We create a new printout report and we say it should be going to the printout report. We set up a certain height and how we want to arrange the pictures on the paper, and then we select the mass print option and set it up. We can select if we want to have the model, the loads, or the results only for selected load cases. In this case, there are not so many. We select just all of them. And then we select from the results which results we want to see. In this case, just axial force, shear force, bending moment. It creates 42 pictures. If I click OK, those 42 pictures are done for each load case, for each force, automatically in the background. Once it's done, as soon as you change something, the pictures will be updating in the printout report as well. You get a preview. The printout report you can export to PDF, for example, but everything is shown inside RFEM. And you see here now we selected 50% of the page should be used for one picture. So we get automatically annotations, everything nicely arranged, 2 pictures on a page. You have different ways how to display the pages, just one flowing page or several pages next to each other, and so on. Good, that was the printout report. Next feature, and I think is the last feature for today, is the so-called result beam. Basically, it's a good step back to the very beginning of this presentation. We have just a one beam model, but it's a surface model. And when we have a surface model, we have different internal forces. We have surface internal forces, mx, vx, stresses and so on, but we don't really know what's the bending moment in the center of the beam or what's the shear force at the edge. And it's really difficult to evaluate it when you see those forces. But if you have like those 1D element forces, then you have a better control and a better feeling about how much load is on there. So it would be a great idea to be able, also we're working with a surface model to see what's the overall bending moment. And for this, you can use the result beam. The result beam, this now is a parametric model again of an I-beam. I hide the supports now. And I see now deflection. Okay, I can understand this, but I see also forces like my, mx, and vx, and so on. But what's the bending moment? What's the shear force in there? It's easy to do this. What you have to do is we create a so-called result beam. You just pick the member type, result beam. just a regular member. Here you can pick it from result beam. It comes with RFEM standard feature. You set up the corridor or the region that should be integrated or summed up for the 1D member forces. You can set up, for example, a certain cuboid, or you can set up a cylinder, or you can just make a selection from certain object. We just integrate all of the objects. We click OK and OK again, and we set just a member in the center here of this model. We'll have to delete the results because we have to remesh them, the member. But this new member, it has a cross section, but it does not add any extra stiffness into the model. It's just a way to summarize all these internal forces, and we do so as if it would be an I-beam 1D element. And then I have these 1D element forces, and with those I can also go in our 1D element add-ons like steel and steel EC3 or AIC to do a design for these 1D elements. So now we show the forces, and you see also member forces now beside the surface forces. You see the bending moment, and we can set up also the display of these bending moments in a little bit better ways, where you can have either without diagram, or you can have it in many colors, or you can fill the result diagram. And that's a very impressive and good display of the forces. And as I said, you could use, for example, this beam element to design for design in steel EC3. So very good way to also check your model for if you've done anything wrong or in the surface model, which is more complex. Okay, before we get to this website part of the demonstration, I would maybe take another look at the questions that we have during this webinar. We have maybe time for a few more questions. Andreas, how is it?
Yeah, Walter, there's a good question for you. The question, are the wind load and snow load generators accessible via API? So you can connect with your own software. That was a question,
okay.
And I think you can answer that.
Yes, unfortunately not so simply, because we have to make a selection which tools we put into the API. Not everything is in the API. We did not do this because we thought, okay, if somebody wants to program the structure, then he has always the way to program also the loads. But at that time when we started to have the API, there were not those wind load generators. Unfortunately, not at this time, but well, I take this as a hint for future developments. Okay.
About questions where, for example, maybe we can show, maybe you can show the RFCOM website. I can't reach the Dlubal website at the moment. I have some problem, but I promise to show the RFCOM website for where the attendees can find examples and descriptions.
Okay, hang on. I show it to you. Just need some. Need to set it up a little bit. Okay. So here's the Dlubal website.
Under products.
So the question was about the RFCOM, where you find the information. Yeah?
Yes.
So maybe on our website there are solutions and products. Solutions is more like steel structures, concrete structures. If you know the product, you look for the product and where it's at, and it's for RFEM, and there's RSTOP, and its COM interface, for example, is under others. And then you get the list of all the other modules that we have, and then somewhere in here you will find RFCOM, RSCOM. If you click on here, you get the dedicated website for it, and then you can read a little bit about it. You have the links to the knowledge base and the videos here, and you can download here the examples. Here's a little tool, a little toolbox, help files, and example macros. You can download it here. Yeah? Also, you have access to the, well, in this case, we don't have a manual because it's all in this table. But for all of those who work a little bit more professional with COM interface, maybe I have another hint. I need to find it. Hang on. With every installation, you automatically install the SDK, and the SDK you can find in your installation at C uses public documents. In my case, it's Dlubal and then SDK. Yeah? So I made myself a bookmark here in the Explorer. So if you just would remember this, you can find it here, and here are all the examples. Here are also the compiled help files for all the modules that we support with the API. And you should use the newest RFCOM 5, which is linked to the new version of RFEM 5. You can still use the RFCOM 3, but it's from an earlier version. So don't be surprised if you download this Excel file that I showed. It uses RFCOM 3, but RFCOM 5 is more complete regarding RFEM 5. Yeah? So maybe that's also important information. Then there are some examples. You find also C# examples, Excel, or Visual Basic.NET, just simple examples that get you started. Yeah? And also on the website, I don't know if I find it now quickly enough, but if you go to support and knowledge base, you can also look for articles about RFCOM. If you choose the product here, you also find here RFCOM. Maybe that's what you wanted to show also, Andreas, but since I'm already here, maybe I can just continue to show it. But of course, I have to
on that page you can also find a lot of.
Oh yeah, I can also go like this. You can say RFCOM. I did that before, so you search for it, and then you see some sample code you can download and so on. You know, if I go here creating parts list, for example, very powerful tool. You can export a certain type of parts list into your Excel. You can get the source file of the Excel, for example. And if you want to see more technical articles about RFCOM, RSCOM, you click on here, and this filter then leads to another selection of COM examples. So for those of you who are interested in this would be actually the correct way to get started with it. Very powerful things, and yeah, I think it's quite useful, and it makes it so efficient sometimes to work with RFEM that you cannot compete with manually work. Okay, that was that question.
Yeah, we are a little bit over time, but I would like to show only the trial version side. Maybe you can show that side.
Okay, then I continue with showing things on the website. Very important is where to download, where you find information. So downloads and info is the page where you find manuals and the downloads of the free trial versions. So everything works for 90 days. So just except our wind, it works for 30 days, but wind simulation, yeah. But download a trial of RFEM, 90 days, and you have all the features like a full version. We have also standalone products that you can use, yeah, and download them from there. In the download region, there is also things like download of models. This is added not too long ago. We have several hundred models that you can download here. You can also have a graphical preview here. If you click on here, it will start to generate a 3D GLTP model. So you can look into the model here a little bit in an animation. Very helpful. Can zoom into it. Very, very powerful thing. Models to download. New page, I think is important to know. Also, I would like to point out our web shop that you find up here. If you have any questions about pricing, you can go here. Of course, also you can order the software. We would be very happy. Andreas, anything else I forgot?
Yeah, maybe only one page, the event page of this webinar, where you can find the next days, the models, the files, the recording, etc.
So if you go to events, news and events, you find all the events that we currently offer. Maybe before we go to the event, also online trainings. We offer a lot of free online trainings. So if you go there, you find a set of trainings. Many of them are free. You can freely sign in. Please check it out. There is in several languages, of course, also. Then event overview or webinars. Webinars, here you find the webinar page, how to be more productive using RFEM. That's today's webinar, and the video will be showing up here on the left side, or then if you scroll down, it will show up down here. And we have here videos from other events, and the models will also then be shown here. That's right, Andreas. Models to download. No? Right. Here you find already some of them.
It's not yet complete, but in the next days you will find all models there.
Okay. Good. Anything else, Andreas?
No, I think we can close the webinar. I thank you, Walter, for the nice presentation. We got a lot of feedback from the attendees that it is a quite good presentation. When you close the webinar, there will appear a survey with.
Oh yes, there's a survey we prepared for you guys. When you close the webinar, please take time and to answer like 5 questions. It will give us feedback how to improve our webinars, and I think that's very important for us, so we can satisfy your needs. Oh, sorry, Andreas, I interrupted you. Anything else?
No problem. I think we can end the webinar. Thanks all for the attention. Have a nice day.
Thank you. Thank you for joining us today, and wish you a nice day. For some of you, it's morning. For us, it's afternoon. So we have to do some after work for the webinar, but we look forward to see you again soon in one other webinar. Thanks, Andreas, for preparing everything.
Yeah, thanks.
Bye-bye.
Bye-bye.